Okay, good morning. We're going to go over a couple of the single proportion tests. So we're starting, this is section 8.3 of the 12th edition. Is that where we are? Yeah. And we're going to look at number 20, if you have that edition, on page 480. So I'll let you read through that. Diltiazem is the drug, right? And causing headaches in about 12% of the patients that are using it. But they think maybe regular exercise might help reduce the headaches. So they take a random sample of 209 patients, give them the drug, they exercise regularly, and only 16 of them had headaches. So we want to know if that's enough to prove that for all patients, is there a reduction in headaches if they exercise? Okay, so when we start these out, we are starting with the null and alternative. And they're different than the first two types of tests that you did because it's not mu. Right? It's just the population proportion of successes. So success would be, what's a success here? 16 had headaches. So a success is a headache. Yeah, that's the proportion that we're looking at. And you know, we're going to see if it has been reduced, but that's what we're looking at, kind of focused on. So make sure that you have the symbol P here. Right, it's not a P hat, because it's population proportion of people that get headaches while on this drug if they exercise. Okay, so is it the same as what it always was, 12%? Or what are we trying to show? What are we hoping is true? Less than. Okay, less than 12%. So we're doing a left-tailed test. Okay, so that's the first step. Second step, pretty short, right? You just got to figure out a p hat. So the sample proportion of people getting headaches. All right, so what two numbers do I need for that? $16 and $209. Okay. So 16 out of 209. Let's just figure that out. I always like to know kind of how closely, how close it looks to that 12%. So 16 divided by 209. Thank you. Whoa, that's about 0.77. Seems like it's a lot lower. We have to decide, though, if it's statistically significant or not. So let's go, if you're going to round it, let's carry it out at least 3 places. 0.0777, because it's 0.7655. So let's go 3 places on that. Okay, so we're ready to figure out the test statistic, the Z. So let's write down the formula for that. I'm going to take that p hat and see how different it is from that 12%. So just a difference between the two. And then we're going to divide by root p naught, q naught over n. Okay, the only one I haven't figured out yet is q naught. So how do I get that? 1 minus, okay. So 1 minus the 12% will be 88. Okay, other than that, I think we have everything we need. So make sure you show this step, right, plugging everything in. So 0.77 minus 0.12 over. Use that 0.12 again, times 0.88, and then what goes in under here? 20, yep, the whole n, the whole sample size, yep. So if you're having trouble, those of you using WebAssign, if it's not coming out the way it should, maybe decimal-wise, It could be that you're not carrying this decimal out far enough. And what some people will do is just leave it as the fraction. So type in 16 divided by 209, and then subtract 0.12, right? Get that. And then divide by that whole thing. And that way it won't be rounded at all until the end. Okay, so at this point you have a couple options. You can either key all that in or go to the testing menu in your calculator. If you're going to do stat tests, which one would we pick? 1 prop z test. Okay, these are always z. Okay, so let's go to the calculator. And I'm going to go through the 2 ways then that you can get this value. Either way, you need your calculator. So I'm going to start out with 0.077, see how it's in parentheses, minus 0.12. Close that off because that's the numerator. Then divide by second root 0.12 times 0.88 divided by 209. So when I do it that way with it rounded to 3 decimal places, it's giving me negative 1.91 for the test stat. All right, let's try it now with the stats menu. So under stat, go to tests, and down to number 5. So the 1 proportion z test. All right, what goes in there? 0.12. How about for x? 16. Yep. Just how many successes you had, and then how many total. So there's the 209. Yeah, so that's all it needs. Same thing that you used back when you were doing p-hat. X over n. And then let's see, I need to pick the correct alternative. We're doing a less than, so make sure we pick that, and then go down and either pick calculate or draw. So I'm going to pick draw here. If you're getting an error message, it might be because your y equals. Look at your y equals. If your plots are on, it'll look like this. So they'll be darker. You want to turn those off. So just go back up to the top and hit enter. And also clear out any kind of algebra things that you might have in your y equals. That might be a reason that that wouldn't work. So I'm going to go through it one more time with the tests, number 5. And then either calculate will give you everything you need just without the curve. So I'm going to do the draw. Okay, so when I did it this way, I got negative 1.93. Is that okay? All right, when I keyed it in myself with those 3 digits, I got negative 1.91. When I use the calculator, I got z equal negative 1.93. Well, that's just what I would have gotten if I hadn't rounded at all. If I had just left it 16 over 209. Okay, so I would take either one, but if you're having trouble with WebAssign taking your answer, it might be that it wants the non-rounded version. Okay. So let's keep it going. Let's say that you kept doing it this way. Then when you find your p-value, right, you're working with a different z than I am up here. So negative 1.91, and shade the same way as the test, right? It's a left-tailed test. So we would be doing normal CDF from negative 10 to negative 1.91. Or you could use the table, the z table. If I do it this way, what's the p-value? Yeah. Do you see it over there? Whoops, put the 3 in. It should have come up when you did your z-test. So it does save you a lot of work. You know, here you have to figure out the z and then go and find the area separately. And if you do it this way, it gives it all at once. It's not rounded, so it'll definitely match what's in WebAssign if you're doing it that way. So 0266. Do you think this one, when I do it, is going to come out bigger or smaller than 0266? So it's not as far over, which means the area is a little bit bigger. Yeah, it's probably a little bit bigger. I don't think it would matter as far as whether you're going to reject the null or not, but just out of curiosity, let's see. So that would be under second, distribution, normal CDF. And I'm going -10 to -1.91. So if you got 0281, you just found it a little bit differently. So you used the rounded off version. Okay, any questions up to there? Yes?
So instead of doing the normal CVS thing, you can just do the stat, like the z-testing on your calculator?
Yeah.
Okay.
Yeah. As far as what I need to see, you know, when you're writing it out, if you've got this on your paper somewhere, then you're all set. It doesn't matter to me how you get the rest of it. So you're either keying it in and then doing this extra step, or you're going to key it in anyway, right? You might as well key it into the test menu. That's what I would do. And then you're sure that it's not rounded, it's as accurate as you're going to get at that point. Yes?
Is it okay to use the normal CDF when you're doing it the other way, like so the top one, it just gave you point?
Oh, yeah.
666, is it okay to do that?
Yep.
Okay, because I got a little bit of a different.
Yeah, it'll still be a little different because that has been rounded. Yeah. That Z has been rounded to fit up on the screen. And so when you do your normal CDF on the -1.93, it won't be exactly that. Yeah, but they're all, it looks like they're all a little over 2%, right? So remember what your alphas are going to be, either 0.1 or 0.5. So see how the next step it's not going to affect that. Okay, did anybody see in that problem what was the alpha level? 0.1? Okay. So if we were to reject right now and say, yeah, if you exercise, you're going to have less headaches, we would be wrong almost 3% of the time, right? We're heading toward 3%, right? We're allowed a 1% error. So what should we do here? Fail to reject. Yeah. Right, our error is just too high. If it had been 5%, could we? Yeah, then we could. But I guess they don't want to tell people to exercise unless it's really going to do them some good with these headaches. So, so we'll fail to reject there. Let's go back and look at the question again and then write up the conclusion. Okay, so back here. Would this indicate a reduction in the population proportion of patients having headaches? So do you want to start with a yes or a no on that? Are we able to show it's less? No, because we weren't able to reject the null. The null is the one that said it was equal. The only way we're going to be able to say the alternative's true is if we reject that, and we didn't. So we'll have to say no at alpha equal 0.1. The data does not show. And then let's describe a success here, that the population proportion of patients with headaches after exercising, yeah, after exercising. Should probably work that in there. Does not show that it is lower than 12%. Yeah. So is the data statistically significant then? No. Yeah, that terminology is only if you're able to reject the null. Okay, questions there? Okay, did anybody not get to fill out the survey that I sent around? Yeah, I'll let you do that real quick because we're going to use that information right now. So we're going to do one more of this type, okay, with proportions. So I looked up voter turnout in 2014, the last midterm, okay? And for college-age students, it was 19.9%. And for overall, it was 37%. It was like record lows on all of that stuff. So we're gonna be looking at you guys. What do you think? Do you wanna leave it as, which one do you wanna compare to? College students or overall? College students, okay. I mean, that's kind of what I was thinking, but. And then the question that I asked on here was, are you gonna vote today or have you already voted, right, in the midterm elections? And not everybody's registered, so, you know, I can't just assume that, everyone who's registered is gonna vote. So I just did a yes or no thing. Okay, so you wanna compare to the 19.9%? Is that what you said? So our question is our proportion, based on our sample, is the proportion voting in this year's midterm the same as it was in 2014? And I'm just gonna put that up here, 2014, for college students. It was, by the way, it was ages 18 to 29 is what that spanned. So I don't know if we're including everyone there, but that's what we're comparing to. And then let me just count these up real quick. So we had 25 people filled out the survey. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 yeses. Yes, you're either voting today or you already did. So I probably should have asked the question before I gave you the results of the data. What did you think it might come out to be? Like, what kind of test should we do? You want to just try and show it's different, or do you want to show it's higher or lower? I mean, from everything you're hearing, you probably think it's higher. That's what I was thinking we could try. Let's see if it's greater than 0.199. Okay, so we'll kind of shorten this from the first problem we did today, because we know that's all we need, right, to get the z. So here's what you could do. Even without figuring out that ratio, you could go straight to this. It's 16 out of 25 that voted. See how different that is from 0.199. Underneath here, 0.199. Now we need the complement of that. What's that? 801, okay. And then divided by 25. Kind of a small sample, but still kind of fun to just see what's going on here. So once you draw that for me and put everything into the formula, you could just go straight to the testing menu. And then that way you don't have to worry about rounding. Did anybody get that decimal though? I mean, are we right to think it's greater?
It's like 64.
Oh, wow. Yeah, 64, 0.64. That one rounds nicely, so it should be the same no matter which way you do it. Okay, so once again, I'm going to stat, tests, all right, and then one prop z, and 0.199 for our null, 16 out of 25. And we're trying to see if it's significantly greater. Right? And so let's let it either calculator draw. Whoa, 5.52 is z. And it gave up after 4 decimal places. If it's not showing any numbers other than 0, it just says 0. Now, if you wanted a more accurate p-value, you could go back. If you did the calculate instead, watch what happens if I do stat tests 1 prop. Just go down and hit calculate. If you're wondering how close to 0 it was, and it tells me it's 1.67 times 10 to the what? -8, yeah. So 7 zeros and a 167. Yeah, we can call that 0. So when you graph that, that's a little harder to graph, right? Because normally we just go out to 3 on each side. Just kind of move your curve over a little bit and still do the 1, 2, 3, and then just show 4, 5, 6, and just at least locate it, 5.52, even though you can't really show any area there. All right, now we didn't set an alpha. We're the ones doing the study. We get to pick the alpha. What do you want to do? Yeah, might as well do 0.1. We could say, oh, yeah, we tested it at 0.1. We could actually test it at 0.001, I guess, if we wanted. And we're going to do what on step 4? Yeah, reject the null. Okay, so according to our data, we can say that at alpha equal 0.1, population proportion of college students voting in the 2018 midterms is what? Okay, greater or higher than it was in 2014 or higher than 19.9%? Either one. Could we have proven a two-tailed on this? Yeah. We would have doubled that p-value, right? But it would still be essentially 0. So. Okay, any questions on that? Okay, just a little bit of review because I'm curious. I wonder what our confidence interval would be on that for our data. So if we were to just say, you know, as an estimate, the population proportion of all college students who are voting in the midterms is between these two. So kind of back up to chapter 7 just for a second. Let's do a 1 prop z interval. Because we've got the data, I mean, we might as well just analyze it to death, right? Stat, tests, where was that? Intervals don't start till 7, so to get 1 prop z int, you have to go to B. Nope, A. 1 prop z int, yep. And then we had 16 out of 25. And I'll just keep it 99. 99% confidence interval since we were working with 0.1. Kind of goes with that. And then calculate. Wow. So between 0.39 and 0.89, pretty much. So we would say with 99% confidence, the proportion of college-age students who are voting this year is somewhere between 39% and 89%. So does that confidence interval back up what we did here? I mean, it doesn't contradict this, does it? Right, here we said, yeah, it's greater than 19.9%. And here we said it's between 39 and 89%. So yeah, definitely higher than the 19.9.
What does it mean when we reject age?
So that means that you have enough evidence from your sample to say, you know what, that 19.9, that's not where we're at now. That might have been where we were in 2014, but ours is so rare. So when you're figuring out the test stat, you're saying, what if that 19.9 is right? Okay, and then we just happen to get a sample of 16 out of 25 that are voting. Maybe that's not such a big deal. If I had gotten a Z-score of like 1, that's not a big deal. Or even 2, or -1, or -2. You know, if it's somewhere in that middle area, it's really not a big deal, and so you wouldn't have evidence to say that the null was wrong. It's only when it's out of the ordinary. So when your Z-score ends up out on the ends like that, that's pretty rare. And that's the evidence that you have to say, oh, no, that null must not have been right. So you're rejecting, right, the null.
When we got the confidence interval, what did we put for the sea level?
I did 99.
Okay.
Yeah, 0.99 on that. That's what that confidence interval is up there. Yeah. I just kind of wanted to see where the numbers ended up. What else? Other questions on that? Okay, I guess we're done then with tests of proportions.